Hello guys, in this video we are going to begin with the graph data structure. A graph is a non-linear data structure consisting of nodes and edges, and this is the official definition of graph. A graph consists of a finite set of vertices or nodes set of connected pair of vertices. So basically a graph is a set of vertices and edges. Okay, here V is the set of all the vertex and E is the set of edges. And to represent a graph, there are two ways in which we can represent a graph. First one is adjacency list and the other one is adjacency matrix. Okay, both the ways are used in different type of problems according to the case, which suits well to the to solve the question in an efficient time. So first we will look at the adjacency matrix representation of a graph. So let us take an example of a graph. Okay, let's take a small graph, not a big one. Okay, and some edges. Let us mark the nodes as 0, 1, 2, 3. Okay, so this is the graph given to us, and we have to prepare the adjacency matrix of this graph. So adjacency, in order to prepare the adjacency matrix, in adjacency matrix, the rows are numbered from 0 to V, and similarly the columns. Okay, so 0, 1, 2, 3, and here to 0, 1, 2, 3. Okay, and we will initialize our matrix with all the values as 0 initially. Okay, and one by one we will keep on updating our matrix as we input an edge. So this is an undirected graph, and we will now just update our matrix. Okay, when we encounter the edge 0, 1, we mark 0 to 1 as 1. Similarly, 0 to 1, if the edge exists and it is an undirected graph, so 1 to 0 would also be marked as 1. Similarly, 1 to 2 and 2 to 1 and 1 to 3 and 3 to 1. Okay, so our final matrix looks like 0, 1, 1, 1, 1, 1, and all the remaining elements are 0. Okay, so it is easy to prepare the adjacency matrix, and the coding part is also easy. So let us look at how to prepare an adjacency matrix of a graph. We will declare a class graph, and we will make the attributes as well as the functions as public int v, and a 2D pointer which will point to our adjacency matrix. Okay, we will write the constructor to initialize our graph, and dj is equals to new int pointer v. Okay, and to initialize a 2D matrix dynamically, first we will allocate a linear column to it, and then one by one to each column we are going to allocate a whole row. Okay, this is the standard way in which we allocate memory to a 2D matrix. And now the each row will be allocated a linear memory and v. Okay, and as I told you, we will initialize all the values to 0, and one by one we will keep on updating the values. J of I j is equals to 0. We initialized all our values to 0. So this is for the constructor, and now we will write a function void add edge, which will input two arguments int x and int y, and it is simple. What we will do is adj of x y is equals to 1, adj of y x is equals to 1. Okay, and one more function to print the matrix. So just loop through all the values. See out it is of some spaces, and after each row enter. Okay, so now I will write our main code. First, let us input the number of vertices, int v n c in v c in, and n stands for number of edges. So g graph g. Now I will input the edges one by one, all the n edges. And we will add the edges to our graph. And then we will print. Okay, so let's run the code. Okay, so we have yeah, it should be just new int. Okay, because we are allocating linear memory, and here c. Okay, semicolon. Okay, so let us take our example. So we had 4 vertices and edges 3, 0 to 1, 1 to 2, 1 to 3, and we get our adjacency matrix 0 to 1 to, and yeah, this is right because we get our matrix as this. Okay, so we will look in the next video how to represent a graph using adjacency list.